This video is about the lesson outcomes for lesson 1.3, collecting sample data. Now, these slides were based on slides provided by Pearson, the publisher of our textbook. Our textbook is Essential Statistics 6th edition by Mario Triola, and then they were modified by me. This covers section 1.3, which is the third section in our chapter over the Introduction to Statistics. So here are our learning outcomes. First, we want to be able to distinguish between an experiment and an observational study. Then we want to look at three qualities of good experimental design, and I'd like for you to be able to articulate those. Then we classify a given sampling method as one of 7 types of sampling methods. So we're going to talk about all 7 of those. And then I want you to be able to classify a method when you're provided one. And then we'll talk about 3 types of observational studies, and we'll want to be able to classify a given observational study as one of those 3 types. Then in our 5th learning outcome, we're going to define confounding, and we'll describe 4 types of experimental design that will minimize this problem. And then lastly, we're going to discuss the difference between sampling and non-sampling errors. And specifically, we're going to talk about random sampling error and non-random sampling error. And we want to minimize all of those errors that we can minimize. And then we want to accept the fact that there's going to be some random sampling error no matter what. So we've got a lot of learning outcomes in this lesson, but I want you to focus on this big picture. So these are the key concepts of lesson 1.3. Our first key concept is that when we collect sample data, that collection of data influences the sphere of validity of the results of the statistical analysis. Most of the time when we collect sample data, we can at a minimum say something about the sample itself, but we may not be able to say something about the larger population. So we want to collect data in such a way that we're pretty sure that this data, the sample, is representative of the larger population, and that method used to collect the sample data will help us determine if that sample data is representative of the larger population. If we do that, then the results of our studies will apply outside of our sample to everyone else. That's the goal. Now, Mario Triola, the author of our textbook, says it this way. He's saying pretty much the same thing. He says, if sample data are not collected in an appropriate way, the data may be so utterly useless that no amount of statistical torturing can salvage them. He's saying it's useless. If you don't do it the right way, it's useless. And again, that's just another way of saying that we're not going to be able to use this data in the way we want, which is as a representative, as representation of the larger population. We can always take a convenient sample or look at a voluntary response sample and find out some things about that sample, but that doesn't necessarily apply to everyone else. And then the third way and the last way that we can say it, and I think I like this way the best, is that a good sampling method leads to a sample that is representative of the intended population. So the types of experimental design that we're going to discuss in this lesson, and the types of things that we need to watch out for when collecting sample data, all of that is relevant because our goal is to understand what it would take to collect sample data in such a way that it's representative of the intended population. And if we can do that, then we can say something about the population when we're done, and that is our goal. So that's it for our overview of lesson 1.3. I'll see you in the next video.